Hi everyone, my name is Ashna and I'm a software engineer at Microsoft, and I work on the upstream team, and my team focuses on open source cloud native projects, and I specifically focus on tools related to security. So today I'm going to be talking about one of those tools, and it's an open source project called Project Copacetic, or Copa, and how you can use it to patch container image vulnerabilities. So why do we need something like Copa? As we know, ensuring images are up to date and free of vulnerabilities is very important for supply chain security. And this is because outdated images can serve as entry points for attackers. And by regularly patching and updating images, we can ensure that any known security issues are addressed. But unfortunately, there aren't many efficient solutions out there to address the problem. So today, I'll start by going over solutions that currently exist to patch container images, and then get into how Copa works and the ways you can use it either with or without a vulnerability report. And then I'll show some integrations of Copa like the GitHub action and the Docker extension. So before getting into Copa, let's talk about the ways you can fix your images currently and some of the key challenges that we face. So your first option is to rebuild your application. So that would mean going into the source code, updating relevant dependencies, and doing a full image rebuild. And while this gets the job done, it takes up a lot of time and resources to complete. Another option is to wait for base image updates. So we would just wait for a new updated version to be released. But with this approach, we don't know how long it could take for an update to become released, and it can also take away control from you as a developer or a user of the image. And sometimes waiting doesn't always work. So if we take a look at this case study, we can see it took almost 2 months for the Ubuntu 18.04 tag to become available. And when it comes to security, 2 months can be a very long time. We also can't rely on the upgrade commands directly because these vary with different package managers, and that would require you to have a pretty good understanding of the base image, and that isn't always the case. And this also won't work if the package manager isn't in the image itself. So for example, if you're using a distroless image, there wouldn't be a way to run these commands. So what do we do if we aren't the ones building the image? And this is where Copa comes in. So Copa is a CNCF sandbox project, and it's a CLI tool written in Go, and it's based on Buildkit. And Buildkit is Docker's default builder, which Docker uses in its backend. And what Copa can do is it can update your vulnerable or outdated packages. And by default, it does this using Trivy. So Trivy is an open source container image scanner, and it'll output CVE information about an image. So Copa will take in this information and target those vulnerabilities. Or you can omit this information, and then Copa will update all the packages to the most recent available version. So this is an example of a Trivy output. So you can see we're calling Trivy image, and we're specifying OS vulnerabilities with the vuln type flag. And that's because Copa can only target OS vulnerabilities currently. And we're also ignoring any unfixed vulnerabilities. And then in the output, you could see the library name, the CVE ID, the severity, and the installed and fixed versions of the CVE. And with this information, we can save it to a JSON file and supply this to Copa. So now that we know what Copa is, I wanted to give an overview of the design. So on the left, you can see that's like our representation of the image. So it's made up of the different layers, the OS, language, framework, and application. And before we get into Copa, we're parsing it with Trivy. And then Copa has now the information of all the required updates. And it can create a diff from the file system bundle and then apply that patched layer to the resulting image. And it does this using Buildkit, and Buildkit has a diff and merge operation, and that's what Copa is using to create this patched layer. And if we were to use Copa in the other way I mentioned previously, we would just skip steps 1 and 2, and we would go straight to Copa and tell it to find all the upgradable packages and apply that as the patched layer. So some of the benefits of this approach is that it gives control to who patches container images. So like we were discussing before, you don't have to wait for any base image updates. It's also a custom patching solution, so you can target different vulnerabilities depending on a specific scanner or update all outdated packages. And this also reduces the time, cost, and complexity of container patching. And since this is a single CLI tool, it's easy to integrate into pipelines. So for example, you could do a build time patch where you patch any vulnerabilities before publishing your image, or you can choose to do a recurring patch. So every Monday you can scan your images, and if there's vulnerabilities, you can patch them. And this kind of goes along to the next point, but you can also integrate this with Dependabot. So for anyone that doesn't know, Dependabot is a tool that scans your repositories and it updates outdated dependencies, and it'll create a PR to update all the references. So similarly, you can use this with Copa by having a patched image pushed to a registry, and then Dependabot will go into your code base and create a PR updating it to the patched version of the image. And finally, Copa can patch distroless images. So if the package manager isn't inside the image itself, Copa will still work since it uses an external tooling image to download the packages. Some of the limitations of Copa are that it can't patch app or language level vulnerabilities. This is because there's no good way of knowing that we won't break anything if we can't go into the source code and recompile an application. It's also not supported with Windows, and it's still dependent on the individual package managers and their accuracy. So I'll get into a demo of the CLI tool itself, and if you want to follow along, you can scan that QR code. So for the demo, I'll patch the same Nginx image we were looking at in the Trivy slide. So we'll pass in the same flags for the vulnerability type and ignoring unfixed vulnerabilities. And we'll run that with the format flag to save it as a JSON file and output a file name. And now that we have that generated, we can pass it into Copa. And by default, Copa will create the same image with -patched appended to the tag. So we're passing in Copa patch, the image name, and the report that we just generated. And you can see it's running apt, and that's because that's the default package manager in this image. And it's also installing all those specific packages that were targeted from our vulnerability report. And now that it's loaded the patched image, we can use Docker images to check that it's present locally. And then we can run Trivy again using the same arguments to rescan this patched image. And now there's 0 vulnerabilities, and we can also run this to make sure we didn't break anything while patching. Cool. So up until now, until the most recent release of Copa, this was the only way we were supporting patching images. But what we realized was what Trivy finds as vulnerable may not be what another scanner finds as vulnerable. So we wanted a way to target all outdated packages. And that's when we added support to update all packages by omitting the report flag altogether. So now I'll run the same command, but without the report flag, and I'll also pass in a custom tag this time so we can tell the difference between the two images. So I'll tag this one as 1.21.6-patch-all. And as it's running, you can see it's not installing any specific packages, it's just checking for upgradable packages this time. And now that that's loaded, we can run Docker images again like we did before. And you can see there's 2 different images this time, and the patched all tagged image is slightly bigger because we're targeting more packages with this approach. And now we can run Trivy on this image, and even though we didn't pass in the Trivy report to target specific vulnerabilities, you'll see that the vulnerabilities are back down to 0 because all the packages now are at the latest version. So this is what the Docker history of the patched image would look like. So you can see the most recent layer is that patch layer that we saw before, and it's created with the Buildkit exporter. And something that we recently optimized was that we would only create one new patch layer regardless of how many times you patch the image. So if I patch the same image 3 more times in the future, we'll only have that one new patched layer based on the updates from the original base image that we started the patching with. And this is so we don't aggregate the layers and create huge images. So another easy way to use Copa without having to worry about any installation is to use it directly in Docker Desktop. So I'll do a demo of that, and if you want to try to install it, you can scan that QR code. So for the Docker Desktop extension, I already have it installed, and you can go in and select the image, either a local image or a remote image. And right now it's only supported with Trivy, so you have to scan the image first. And then you can see the vulnerabilities and click patched image. And this is the same output that we were looking at before, since it's just running Copa in the back end. And now it's patched the image, and then we can click Scan Patched Image to make sure the fixable vulnerabilities were addressed. And now you can see it's showing 0 vulnerabilities. So this is really cool because you don't need to install anything locally or run anything locally. You can just go into Docker Desktop and patch your image. So finally, another integration of Copa is to use it directly in your pipelines. So You can either install the binary and call it within your pipeline, or you can use the GitHub action if you're running a GitHub workflow. And this takes in all the same arguments that Copa takes in, so the image, the report, patch tag, timeout, and it'll handle the connection to Docker and loading your patched image. But if you are trying to patch a local image, you need to supply the custom socket. So the only way Copa can patch local images right now is if the containerd image store is enabled. And this also has to be patched with the Trivy report. We don't support updating all packages yet in the GitHub action. And this is basically a flow that you can expect when you're running Copa in your pipelines, and it's similar to what our team does. So you can generate a Trivy report, check the vulnerability count, and then run Copa if it's needed. And then you handle the authentication to your registry and push the patched image. So next steps for Copa that we want to support is multi-architecture patching. So we want to improve the user experience because right now for Copa you have to individually patch each architecture image, and it would be better user experience if we could do that all at once. And similar to that, we want to support bulk image patching. And finally, we also want to support some of the newer features that we release in the Copa in the Docker extension and the GitHub action. So like updating all outdated packages, we would want to support that in the extension and the action as well. And now that we've covered Copa and ways you can use it, I wanted to encourage everyone to get involved. You can find us at our GitHub repo or the CNCF Slack channel, and we have ad hoc community meetings bi-weekly on Mondays. I've also linked the repo for the GitHub action and the Docker extension, and you can find all these links in the uploaded slides. And these are also some links to the resources that I have referenced. So Buildkit, which is what Copa relies on to do the patching, Trivy, which is the scanner, and the Copa scanner plugin template if you want to try Copa with your own scanner. Thank you. Does anyone have any questions? Yeah.
Is there something a mechanism for preventing rollback attacks using the patching?
What do you mean by that?
Like tricking the patcher to install an older version that is even more vulnerable?
I'm not sure. I can get back to you on that, yeah. Yeah.
Apologies, I arrived a little late. Would you please define Copa and Trivy, just kind of making sure of the presentation?
Yeah, so Copa is just a CLI tool, and you can use it on container images to patch them of their vulnerabilities. Yeah, and then Trivy is a open source container image scanner. So it outputs CVE information based on the image you supply in. Any other questions? Okay. So by default, it supports Trivy, and we had a community contribution for a gripe scanner plugin. Those are the two that exist right now, but using the scanner plugin template, you could make your own too. Okay, thank you.